Good morning everyone. Let us now see about power amplifiers. Power amplifiers are used to amplify power or current. So it is used in radios, TV receivers, tape recorders, CRT, cathode ray tubes. So here this is a general characteristic curve. So here class A, class B, class C are different power amplifiers. So how can we identify whether it is a class A power amplifier or class B power amplifier or it is class C power amplifier? The efficiency of all these classes will vary. So we need to select the Q point such a way that if the Q point is in the middle of the load line, then it is a class A power amplifier. If the Q point lies exactly in the x-axis, it is class B power amplifier. If the Q point lies below the x-axis, then it is class C power amplifier. By this, by knowing the Q point, location of the Q point, we know that whether it is a class A or class B or class C. Looking into it further, what is class A power amplifier? So here in class A we have two types. First is the directly coupled, other one will be the transformer coupled. So this is the general block diagram of or general circuit diagram of directly coupled. So this is fixed by a circuit. We have the load resistance across the collector circuit and the biasing resistance in the base of the transistor. So this is a directly coupled circuit. So first we are going to select the Q point such a way that the output is obtained for a full input cycle. So from this operation, Q point is selected at the center of the DC load line. So only when the Q point is in the center, see, note it, the Q point is selected at the center, then it acts as a class A power amplifier. The transistor is on for 360 degree. So for all the values of the input signal, the transistor remains in the active region and never enters into the cutoff region or saturation region. The collector current flows for 360 degree of the full cycle of the input signal, and hence we get a faithfully reproduced signal without any distortion of the output. So this is the class A amplifier. So we can see the analysis of class A. So first we need to obtain the Q point. So by applying KVL to the input circuit, so if I apply KVL, VCC minus IBRB minus VBE equal to 0. So if I apply KVL to the output circuit, I have VCC minus IC into RL minus VCE equal to 0. By substituting this and taking the value of IC as 0, my VCC value will be equal to VCE. So if I substitute VCE value 0, I can calculate my IC. IC is equal to VCC by RC. So then writing KVL to the input circuit, VCC is equal to IBRB plus VBE. I can calculate my value of base current, and from base current IB, I can calculate the collector current, from which VCEQ. So if I know ICQ value and VCEQ value, I can find the Q point from the DC load line. So we can calculate the Q point here. How to calculate the DC power? The DC power input is provided by the supply. So with no AC input signal, the DC current drawn is the collector bias. So here, what is the collector current? ICQ. So power is equal to voltage into current. Voltage is the direct voltage which we are getting from the supply VCC into the collector current IC. So by which we can calculate the DC input power. So how to calculate the AC input power? So we need to know the peak to peak value. So that is the maximum to the minimum value, the difference between the maximum and minimum value. So what is the maximum value? The peak value, peak to peak value divided by 2. So what is peak to peak value? It is the difference between the maximum and minimum value divided by 2. That will give you the maximum voltage. So in the same way, peak to peak current, maximum current. So it is a difference between maximum current to the minimum current. So we can calculate the maximum current. Now we need to know the RMS value, root mean square value. So to the maximum parameter, so whether it is voltage or current, we need to take root 2 in order to get the RMS value or 0.707. So we can calculate power is equal to voltage into current. So AC power we can calculate. So by substituting the values, we are able to calculate the AC power. And what is the efficiency? Ratio between the output power to input power. So ratio between output power AC power to DC power. So maximum efficiency, if we need to calculate, we can take the value Vmax as the full supply voltage VCC. And minimum value, let me consider it as 0. And maximum value of current we can substitute it as 2 times of collector current. Minimum value I can take it as 0. So if I substitute, the efficiency will be 25% for class A amplifier. So this is the transformer coupled class A. So in the previous case, directly the load is being given in the collector circuit. So here now we are giving transformer to the load. So here I am going to keep a loudspeaker connected to the secondary of the output transformer. So the load is connected directly to the output circuit. So the current passes through the resistor, resulting in considerable wastage of power as it does not contribute to the AC signal, and thereby this may decrease the efficiency of the amplifier, and hence we are using loudspeaker as a load. Let me now consider class B amplifier. So for class B amplifier, Q point should be located on exactly on the x-axis. So for the operation, the collector current flows only for a half cycle or for a full cycle of the input signal, and the output signal gets distorted. So to get a full cycle, a pair of transistors is being used. So we have two transistors which conducts in alternate half cycles. So for the first cycle, one transistor will be on, and for the other cycle, other transistor will be on, vice versa. But the two transistors are identical in characteristics, and they are called matched transistors. So see the construction. We have two transistors, Q1, Q2, and when one transistor is on, other transistor is off, and when the other transistor is on, other IQ1 is off. But both have the same characteristics. So one transistor is pushed to conduction while the other is pulled out of conduction, which is cut off. So hence we call it push-pull. So this is the operation for the positive half cycle. So here we have the terminals A and B. So Q1 is driven into active region, Q2 will be in cutoff. Hence the current IC1 flows through the upper part while IC2 is 0. So for the positive half cycle is produced across the load. So I get an output at the load. During the negative half cycle, the terminal A is negative whereas terminal B is positive. Q2 is driven into to the active region. Q2 becomes active and here Q1 will go to cutoff. So IC2 current will flow and output is produced at the load. So a full cycle is obtained at the output. So this is the input source current. So this is the first output. So this is the second output for the base. So this is the collector of the transistor 1. This is the collector current of transistor 2. So hence at the output we get a continuous wave at the output. So this is about class B amplifier. So when you see the analysis of class B, so here first we need to find the DC current. So the DC current, we know that as two transistors are working, so first transistor produces an output Im by pi, the second transistor will produce an output Im by pi, so we get 2 Im by pi. Next we have to find the DC power. So DC power is equal to voltage into current. So already we have found the DC current. So hence we are able to find the DC power. Next we need to find the AC power. Next we need to find the efficiency. So to find the maximum efficiency, consider Vm is equal to VCC. So the efficiency comes nearly to 78.5%. In class A amplifier, we obtain 25%. But in the class B, we are able to get 78.5%. So the efficiency of class B is good when compared to class A. Thank you.